Thank you for joining us this morning. Today we have our second progress presentation, and you're going to have these two presenters. So right away, I'm going to return back the mic to the first presenter so that you can take over. So Mina Gilbert.
Yes, please.
I've made you the host so you can take over.
Okay.
Proceed. You're going to have these two presenters. So right away, I'm going to carry on. So you can start your presentation, what you want to show us.
Okay. I am Gidaiga Dennis Derito, and my colleague is Mina Gilbert Kusho. Our project is the performance of reinforced recycled plastic lumber as an alternative timber, and our supervisor is Dr. M. Galimba. Now, in the recent past, timber has gained popularity in the construction industry due to its versatility and also due to the fact that it is a renewable natural resource. It is also non-toxic and easy to work with. However, increased demand for timber has led to uncontrolled logging, which stretches our diminishing forest resources, leading to deforestation. Now, according to a report carried out by Wu and Wang in the year 2007, it replaced the national wood deficit at 10,328,134 cubic meters. Now, in the face of these challenges, we therefore need to find an alternative material so as to reduce the over-reliance on timber and also save our forest resources. Now, over the years, various researchers have carried out research on the potential of plastic recycling. The implementation of these researches has led to production of recycled plastic lumber. Now, plastic lumber is a wood-like product made from recovered plastic. However, the limitation of recycled plastic lumber is their raw modulus. Various researches has been done to improve on low modulus on plastics. For example, Jijenge Kenya, some have used the addition of sawdust. For example, Jijenge Kenya have used addition of sand to increase the modulus of elasticity on the plastic. On our proposal, we will add the wire fibers from waste tires. A few years ago, the government of Kenya banned uncontrolled tree logging to calm the deforestation menace. In this way of the ban, alternative timber would be very timely. Recycled plastic has been investigated previously, but its weakness is low modulus. And to improve on low modulus, we shall use the wire fibers. Now, our study objectives, the general objective is to investigate the performance of reinforced recycled plastic as alternative timber. Our specific objectives, number one, is to determine the mechanical properties of reinforced recycled plastic lumber and unreinforced recycled plastic lumber. Number two is to compare structural performance of reinforced plastic lumber with conventional timber. And number three is to compare the cost of reinforced recycled plastic lumber and conventional timber. Now, the scope and limitation. The study will focus on laboratory tests based on material investigation. The research limitation are resources and data. Now, literature review. The focus contains a review of research work done by various research workers related to the present studies that gives the general information on plastic lumber. Now, here is the work of various researchers, their findings, and the critic. And for example, here we have an author by the name Whitehold and Lever. In the year 2014, their study was on the mechanical property of plastic lumber produced from recycled high-density polyethylene, HDPE. They found out that the mechanical property of recycled material was below the expected range. The critique was that the recycled plastic lumber composite has very little capability to resist the tensile load. Now here is the work of other researchers. These Diaz and Alvarez in the year 2017 They were investigating the mechanical properties of wood rubber versus plastic rubber and thermoplastic composites. And they found out that the extremely high values of compressive strength shown for the studied experimental thermoplastic composites compared to wood reveals their great potential used in compressed elements. However, the recycled plastic rubber showed raw modulus, which can be translated into high deformation compared to timber. This is a real limitation for the usage in civil engineering and building applications. Now, these are other researchers which I will not go through. The summary of the research gap. While appreciating the work of various researchers, raw modulus of recycled plastic rubber inhibits its application as a structural member. There have been attempts to improve the raw modulus by trying combinations of different materials, e.g. fiber reinforced RPL and wood feed RPL. Now, our study will be carried out on how to reinforce recycled plastic rubber using wire fibers as they are good intention, hence providing alternative timber, plastic, and tire waste management in the country.
On research methodology, we will first do the correction of material and fabrication of mold. The second layer is melting of plastic, then squeezing of molten plastic into a mold and addition of wire fibers in molten plastic and laboratory test. The figure shows the fabricated mold that we have fabricated. On the second figure, it shows how when we are preparing the molten plastic using extruder mechanism. This you can see from the picture. That is the figure showing the molten plastic being squeezed into the mold to the mold. The next, this is after cooling the plastic mold. This is how it was produced. The first figure shows when it is on a mold, and the last figure shows the exact mold. The test done included comparative compressive test for the 3 samples, comparative tensile test for 3 samples, comparative bedding test for 3 samples. Then we shall do the cost analysis, which will be carried out by comparing market price of convection timber and reinforced recycled plastic lumber and the reinforced recycled plastic. And result and analysis. So far, we have able to do the compressive strength of one reinforced plastic lumber. As you can see, we had 3 samples: sample 1, sample 2, and sample 3. The first sample has 21.453. Second sample had 20.326. The third sample has 20.46, and the average compressive strength was 20.753 megapascal. On the second sample, we did for reinforced plastic lumber. Average compressive strength was 22.338 megapascal. This was our work plan, and this is the budget, and that is the end. Thank you.
All right. Well, I can see there is some progress there.
Yes.
It's commendable, but still there's some room for improvement. So
yes.
First, let me mention this to all of you who are listening.
Yes.
Why I said that it's mandatory for every one of you to attend this seminar is because whatever the comment we give to the first presenter or the previous group,
yes,
the same issue, especially if they are just a broad error or a broad comment, they should not appear in your work, is it?
Sure.
Because you listen to what we make the comment to, like the first group we presented to, they presented to us was Mohammed and what are the other group? The other group for, it's not Kidavi, it's this group. But anyway, what I'm saying is the comment that I made last week, at least they should not appear here. And one of the comments I made is that this is a progress.
Yes.
So it's not a proposal. And by progress, meaning there's some work that you have already done, as you have shown us in the result. But until the stage when we came to see your result,
yes,
we could not tell. We were thinking it's a proposal because the tenses were still, this will be done, this will be done. Even in the methodology, you are saying this will be done, the mode will be fabricated. But later on, you come and show us the figures of the mode. So need to change those tenses.
Okay.
For the work that have been done, you should tell us that this is what was done. This is what
Okay.
was that. We know this is a progress. So for the last objective about maybe the cost analysis, this now you tell us the remaining part of the cost analysis. This is now what will be done. So your work for the progress will be composed onto until the time that you finish. It'll be composed of two tenses: the past, and even three. The past, what have been done; the present, what is currently ongoing, and even the future tenses. So that's just a small observation for, and those people who are presenting later on should note that.
Yes.
Then the other thing is, can you go back to the first slide? Let's start with the first slide. Not the first. I mean, okay. Sorry. Another thing before I leave here, the general comment to everyone else. This in the progress, we don't need to see the budget. This was in the proposal. You know, it's like when you want funding, you write a proposal. It have to have a budget so that it's approved. After it's approved, there you work with that. So you don't need to keep showing us that.
Okay.
About the time plan, the work plan. The work plan, whatever you are showing us, this is the what can I call it? The master work plan that you had in the proposal, right? But there is now how you are achieving it. So it's better you show us, like in the objective one, you show us what has been covered, what is remaining in terms, and then you tell us the percentages. Yeah.
Okay.
If for example in objective one you are going to tackle 4 tasks and you have been able to achieve 2 of them. So you can say then all these, you can show us this experiment or these tests have been conducted, and therefore we have covered 50%. Okay. So now you need to, you don't just keep showing us our previous, I mean the overall, what we call the master or work plan. That is to guide you. We need to really know where you are at this stage, because now the question that comes in now, I would ask you, how far are you with your work? What can you tell me?
The progress is good.
That is quantitative. I want quantitatively. Quantitative is where you give me quantities, tangible quantity, yeah, tangible values. Qualitative is I can say it's a good progress. We are moving on well. Qualitatively, but quantitatively, we need values.
For the compressive test, we are 90% done. It's only a small portion.
Yeah, those are the things I'm saying. You should have a summary table. Of course, it aligns with the master work plan. But now it's showing us the execution. This one you should look at hard. This is FIBRE. You've already learned. I don't know whether it's civil engineering practice or it's engineering management, where you are doing those Gantt charts.
Yes.
Yes. So once, I don't know whether it depends with who is teaching, but once you are taught how to construct one, even when you go to the site, you see now during progress meeting, they show us like this was what we anticipated. So this was from the master work plan, but up to this moment, this is how far we have come.
Yes.
Yeah. It helps you to keep you on track, to track your work and to know where you are lagging behind. Because like for now, I'm looking at what you've done.
Yes.
And somehow at the back of my mind, now I'm starting to realize there's some, I wouldn't say it's an error that you're doing, but kind of there is a missing link, because you've showed us the result for, just go back to your objectives.
Yes.
You showed us the result for plastics. But I was wondering, why are you not showing us the result of the timber first? Because what is your control?
It is timber.
Then that control always starts. But then I realized it's from the arrangement of your objectives here.
Yes.
That the timber is coming in as the last. Is it in the second and the last objective?
Yes.
So it means now, from the way we have seen result, even you yourself, you can see, we started we left the control behind, and then we started with the variable. So you need to rewrite something here. You need to include in the objective. In the first objective, that you have to determine the mechanical properties of conventional timber.
Yes.
And the recycled plastic lumber.
Yes.
And then the second one is where now you compare the structural performance. And the third one is, okay, and cost. So it means now the first objective need to be refined.
Okay.
So that we first need, in the next presentation where you're presenting the department, they didn't need, that's a question that will come up. They needed to see the performance of the timber because you already started the control.
Okay.
And then the word conventional. The second objective is okay, but in the third objective, you are talking about convection. Okay, so note that.
Yes.
Then this is about the form, the arrangement. I remember the last time I was telling you about the screen sizing. Now you've changed the screen size to be, I think, 16:9 ratio.
Yes.
But you are leaving a lot of space on the sides here. Somebody may wonder why.
Yes.
And you try that. You can even try to fill it up and then you can space your text.
Okay.
Then on the problem statement, although I know this one we talk too much on the objectives in the proposal, but in the problem statement, I found some statement here. The way you explained it, I have no problem with the way you have arranged it, but the way you explained it, I found it to be a repetition of a statement you made in the background information. The exact same statement. Is that true? The way you are saying, in the wake of the government, in the wake of the government, you talked about the government directive on banning logging of tree.
Yes.
And you talked of in the wake of this, and you have said the same thing in the background information. Repackage your, because as problem statement, of course, it's derived from the background information because you've already given us a big problem. You have showed us the existing problem. But repackage your wording. You don't let it not be seen like you are just reading the same statement twice.
Okay.
Okay, it's very important because people will see like you are repeating. Of course, it's built up from the background, the problem statement.
Okay.
Then after your presentation today, because we continue improving our work, I found the word modulus to be a key thing in your work, is it?
Yes.
And it would be necessary in the background.
Yes.
If you could at least tell people what is modulus and what is the low modulus of this material.
Okay.
In a very summative form.
Yes.
Let people know what you're talking about before you talk about the problem statement, that the issue of low modulus. For the sake of those people who might be, they are in engineering, but maybe they are not in structural engineering. If somebody is in water engineering and he talked about this in undergraduate 20 years ago, he might have forgotten what is it. So, and even for other people who might be interested in your work, but they are not in engineering, let them just have a brief understanding of what is this problem that you are talking about. Okay?
Yes.
Then on scope and limitation, I think this one we had talked previously. I don't know whether it's this group or another group. The scope and limitation. Yes. Okay. Sorry for that background noise. I was trying to quench it. On the scope and limitation, here, okay, this slide.
Yes.
When you say the limitation is the resources and data, we were talking of being specific.
Yes.
Because somebody, of course, we are always limited with finances and funds, but what is so specific about your work, right? And that's why I had been disregarding those people who are talking about time and budget constraint. It's always there for any project in life. You don't have, you don't have unlimited time. You don't have unlimited budget. But if you can narrow down and say, this and this test will be done because you're saying this and this test cannot be done because of lack of this, people know that you're not just being so generic.
Okay.
Yeah. Something to improve on.
Dr. Can I ask you a question about the limitation?
Yes.
So far, as we are trying to gather information about the tests, to do tests, we have visited JKUAT and carefree. And we found that we cannot able to do the tensile test.
Why?
At carefree, the machine is defective. It is not working.
How about in JKUAT?
And we don't have JKUAT. I think it is for concrete works mainly.
No, the tensile machine.
They are saying on tensile machine,
we need
we need a circular mode.
A circular mode.
Oh, for the for the
Yes.
because it's used to grip the bar. That's a very short challenging. But without the tensile test,
Yes.
I mean, you know, this material, what is the ultimate purpose of doing this test? What are you anticipating? You're anticipating that it will be used in maybe
Structural.
trusses, structural trusses, and even posts. So when you talk of bedding, you cannot eliminate compression and tension. Yeah.
Sure. Mm.
I think that's a very unique, important test, and you might need to rethink it. I know I have a master student who is doing something in University of Nairobi. You might need to contact. I know you have some limited budget, but I don't think, especially for undergraduate, maybe just the fare will be the issue. And when you meet the guy in the lab, I told you to be smart. Be a bit generous.
No,
you can buy them some.
To be specific,
Mm.
like that, to be specific, on carefully, we wanted to do our test there.
Okay.
But the cost is too expensive. We saw that the cost will come up to 8,000.
Carefree is a research institute. You know, that's business.
Yes.
But I'm talking of initially like University of Nairobi or TUK. Yeah.
Okay.
Because at least there are other tests we can avoid, but without tensile test,
yes.
I mean, our work is, we are so limited.
The guy at our lab at JKUAT was proposing we can replace with fracture or test.
Fracture is on bedding. How are you and as a person to get the, because what I'm looking at, we needed to see what is the tensile strength.
Okay.
But from fracture, you are going to get the movement.
Okay. Sure.
Yes. How are you going to get the strength? So think about that.
Yes.
Otherwise, this is your research. I know these are basic material tests, but that's an important and a very, very basic and significant test.
Okay.
Yeah.
Okay.
I know now, like the limitation here. For me, you already told us the scope is on laboratory test.
Yes.
If you don't want to say it's on material only, it's okay. But then you come to the limitation. One thing that should come out is that you are focusing on basic material test. You're not doing a structural element. So somebody should not expect to see a truss.
Yeah.
Okay. So that's a limitation. Because the work we are talking about, and when we talk of TIBA, people will be interested in seeing and then what comes to their mind is the structural member that comes to their mind, or the structure that comes to their mind is a truss. But for you, that's a limitation. You don't have the resources to fabricate, because by the time you come up with them, you need some enhanced budget. I think this work, if it was like 20,000, you could have made a simple truss.
Yes.
So that's where now the limitation can come in. The other one you can say is a limitation, the availability of testing equipment. But as I'm saying, then if your work cannot be done, if the basic test cannot be done, you not have results for comparison. You not have like the bare minimum.
Yes.
Yeah. There is another machine, I don't know whether it's still working, in mechanical lab.
Okay.
The tensile, it was a UTM. I don't know whether it's still working. You can try to look into that.
Yes.
Yeah, you see whether you can, at least the tensile test is okay. The others, tensile compression, bedding, those are kind of basic. If you do not do that, then you will not have results. I mean, you don't have significant results.
Then we are asking, because for timber, it has already been done and there are data about timber. Can we use that data without testing the timber?
It's okay. It's okay. You can use secondary data. What you need to know is that you need to have the information about that material, because like the timber, we have different species of trees. Yeah.
You are using cypress.
Yeah, you need to have all that information. Like you own up that data. You kind of get from where you are getting it from. And I prefer it to be timber from local available timber.
Yes.
Okay. I mean, why should you go to just the internet and look all that and you are trying to solve a local problem? Okay.
Yes.
If you can get adequate data, I think it's okay at this level.
Yes.
Although our purpose was also to test you whether you can be able to do some laboratory tests. You know, these are the graduate. One of the things that we are doing is the experiment that you've been doing, refreshing. Some of the tests here you are doing, you learn them in second year. After
Sure.
that,
Actually,
yeah.
we had a timber specimen at the lab, and it gave us some figures. It is actually very high. It is not matching up to these plastics.
You don't expect it to match up.
Yes.
You don't expect it to match up with timber.
Yes.
The issue is about attaining to the basic, to the minimum values, the standard for the design. Okay.
Yes.
It might, depending with how you reinforce it, but when it's unreinforced, no, you don't expect it to do that because that's just a plastic matrix.
Yes. Okay.
Yeah. So another thing I'm saying is that at these other graduates, we are also testing your skills in how to formulate a research problem, conduct, set up the methodologies, the procedures that you can follow, and come up with results, present them. You know, the whole essence is not just about getting some result, whether good or bad, but the process itself. Because after this, now you go to the field. Some of you may never come back to study again. Yeah.
Sure.
So you may find like you have said sure very quickly. So so in the field, but when you go, let's say you become a materials engineer.
Yes.
Yeah. You don't want to be so raw from class. You just have a degree, but everything is you are being shown by the guys in the lab, the technicians. You need to have the theory. You should be able to have a hard-on experience. That's one of the things that we are doing here. Okay. That's why I was saying, like doing the tests, many tests. If you select the secondary data, too much of it, then you end up not doing any experimental testing.
Okay.
Yeah.
Okay.
All right. In the literature review, this summary is okay. Why are you just putting one? Oh, okay.
It was because of time. We were limiting ourselves so that we don't use more than 5 minutes.
Of course. No, I'm saying, can you go to the previous slide? Yeah, I'm wondering why this is not the last slide on the review, but why do we have a blank on bottom, but on this other slide it's full? You know, this is about arrangement.
Yeah, we have seen the mistake.
It's not more of mistake. It's like you know, people, the human beings, they are programmed a certain order. Somebody may think this is the last slide, then he sees the other one. I like this system of literature review, but it's also good to, okay, you don't have time, but this being a scientific work, a scientific presentation, it's also good to show something concrete.
Yes.
The finding, you're saying the mechanical properties of recycled was below the expected range.
Yes.
Yeah. But if you can have a value.
Okay.
Yeah. You're saying the mechanical properties of recycled materials below. What are these mechanical properties? You can have if it's tensile or if it's compressive strength test or if it's even the modulus of rupture, you can say, for example, this value was this. You don't even have to talk about it. You can make the statement, but you have put a summary showing us some figures, some values. I mean, so that people can see what was this, was this that was below the range.
The range.
Yeah.
Okay.
Can you go to the next slide? Oh, we need to move a little bit faster. The one for the summary. Yeah, you're saying low modulus of recycled plastic rubber inhibits its application as a structure, remember? Okay, that's okay. This statement could or could not, it could imply to some people that this material you are using, the plastic, is a tube or lumber, that it have never been used as a structural in structural works.
Yes.
But I remember in your document,
yes,
you have some very good bridges. Is it?
Sure. Yes.
Are they made of plastic or are they made of FRP, reinforced FRP?
Oh, it is only the deckings. The decking, that
And
was,
in your background, did you show that? Because that, I think those figures are very important. That's why I was telling you to include them.
we have not shown that.
They are very good in explaining your work, to make
Okay.
other people understand.
Yes.
Okay.
Okay.
Then this way I was saying, the study will be carried out. This way you need to change the tenses because it's a problem.
Okay.
Now, where I have a big issue
Yes.
is in the methodology and resource section. And this is the core area of your work. We are not in the proposal. In the methodology, yeah, this is a good procedure, okay? Move to the next. Here now, we need to see the details.
Okay.
Like we need, before you can show us the photo,
Yes.
you need to show us the skin. You need to show us the detail of the mold. As simple as showing us what is the length, the breadth, the depth that you selected. Okay. We need to know where is this melting being done?
Light industry.
Okay.
Yes.
So I also thought that it's good to see the melting and where you are using the fibers. Have you shown that, or it's in some other work, the future work?
It is on the future work. We had the photos, but we have not finished doing the work.
So show the details here.
Yes.
Then explaining the protrusion, the production of these molten wax. Yes. I know people will be very interested.
Yes.
People need to know, like, because in your photo you are just saying this is a photo showing this, this is a photo showing this.
Yeah.
People may want to know what are kind of the typical temperatures. I don't know whether those machines have got the gauges, because somebody may want,
they don't have gauges.
Because somebody may want to reproduce your work.
Yes.
Okay.
Yes.
And then I'm seeing like when this molten plastic comes out, you are collecting using some kind of, is it a spatula? Some kind of not spatula, like a pan.
Yeah.
So the issue of placement, also people need to understand how you placed it. So say something about this photo when you are showing them, because this is a key area. This is a core area in your progress. And especially when you are presenting for award of mark.
Yes.
People will be interested. The methodology, the procedures that you followed.
Yes.
Move to the next slide. Because one thing that I'm seeing,
yes,
we could have made this progress earlier on. There's the cross section. The cross section. I'm looking at the photo and I'm thinking,
yes,
the sizes that the choice that you made. What are these dimensions? Are they relatable to the size of the timber that you use?
Yes.
What's the depth?
100 by 50.
Oh, okay.
Yeah.
On site we call it
4 by 2.
4 by 2.
4 by 2.
Okay.
Yeah.
Okay. What is this? The white surface. This is the plastic itself.
We had a plastic of two materials, but they're of the same quality, HDPE. The first two was white, and the other one was black. That was due to the availability of material.
But plastics, you could have gone with the same type. Why? What is it about being unavailable?
The color.
Not the color. The color. I'm talking
the
about
material of the same quality.
They
are both HDPE.
Yeah, that's another thing I'm saying.
Yes.
There is a lot of information that is lacking in the methodology. We need to see this material. In fact, just seeing the plastics themselves, if you have some photos.
Yes.
Yeah. The plastic, people need to see a scheme, like how they were chopped, then they are fed into that incinerator or whatever you are calling it, then coming out. You can have some very good, not just the photos. The problem with the photos are good, but the problem with them is that if let's say I print in Ankara, you not be able to see that. And also the other thing is that sometimes the mind of the people may not be visualizing the way you are visualizing. But if you can have a scheme, like a sketch, a flow chart, in addition to the photos, you are showing us first, like you show us you show us we can see the plastic. This procedure you are talking about, correction of material and all that. Let's see those plastics that you're using, the photos. Then you be using an arrow diagram, a flow chart. You show us now how they were chopped. We can see if those. It doesn't have to be you. If it was done in light industry, you can take a photo. I know they do that. You can take a photo where they have chopped off those small pieces. You show the procedure, the flow. So that by the end down, when you are telling us, this is how now you are showing us the photo of the plastic being extruded, the person, somebody looking at your work for the first time have gone through the flow. Now he can appreciate those photos.
Okay.
Photos are to supplement your work. They are not a key thing, they are to supplement.
Okay.
Yeah. So the next slide. So supplement that, improve on this so that people can quite understand, because sometimes the photos are not quite clear, like just looking at them, you might not quite understand what's happening here. Yes. Okay, next slide. Okay, then next one. Oh, I was talking about this. We also need to see. Okay, you can talk about how you finished up this, because people know that this one you placed it in molten stage, it was hot. Yes. Right? But how did you obtain the finish? Okay. Those are minor details, but they are also good to make people understand that they can reproduce this work in the future if they desire to do so. Yes. Then next, these are the tests that were done, not to be done. Okay. And there is no test called comparative. Comparative, that is analysis. It's not a test. You are comparing. So the tests are comparative test, tensile test, bedding test. Those are the tests. Okay. Yeah. Then you are saying you did the 3 samples, Yes. Okay. You have very limited results, You see now here, you should have shown us the result you are talking of the TIBA, the secondary data, because now we are trying to compare. I mean, yes, we can see the graphs, but how do we discuss these results? We need to discuss them in terms of yeah, okay. Where are the like your graph need to have some additional information. Let's say what are the typical for the TIBA or the control that you're going to have, or what is the minimum requirement if you're going to use maybe like that BS for TIBA is, I forgot. 63.99 is for loading, 59.50 is for steel. For TIBA it was something 60 something. So there is the permissible stresses. Okay. So we may need to, when you are discussing results, it's good to you need to read the previous work, like the papers you have been reading. You can read at how they are discussing. Otherwise, if you just present results like these, okay. And you can see they are just graphs, but you might not really know what is happening or what is the significance of these results. Okay. And then the results should, of course, follow with the objectives. Objective 1, the result should be for objective 1. We start with that, we finalize that. Yeah. Yes. Then in the methodology, before you count here, or even here on the side, maybe on the side of this, you could have shown us the photo for the compressive strength test. We have not seen this specimen, because if you go back, can you go back? This specimen, go to slide, I think, next, this one. Yes. This specimen, we are seeing a kind of a rectangular piece. It have got some, we can see the cross section, but we can see the length. Yeah, it's a long, kind of a long specimen. I mean, what am I trying to say? Yeah, we can see this dimension. We can try to assume that the distances. Once you say 150 by 50 by 100. But now my question is this the same specimen that you did the compressive strain? And if so, how did you test it?
No, it was a smaller size.
Yes, that one we cannot see it. We need to see the size of that small specimen, the dimension. Yeah, both the photo and the sketch. Just draw a cube, show us the dimension, show us the load application direction, and then we can now appreciate that you did not do, because now somebody may just think that you are testing this, and when you test this is like a strat. It's like you are, somebody may start thinking of, oh, how are the backward issues tackled?
Okay.
Yeah. So you need to show us that specimen that you conducted the compressive strength test, and also it also helps us to know that you did this work.
Okay.
So show us that, show us the dimension, show us the loading, and also the photo in the machine.
Okay.
Okay. Then the same case for the compression, for the fracture, for the tensile also. Yeah. Let's see those tests.
Yes.
Okay.
Okay. Yes.
And let's see the measurement of the specimen that you did for each of the tests.
Okay.
Let's also see the arrangement. You know, we don't know in the fracture. Can you go to the result? You have shown us for the compression. Have you shown us for the bedding?
Not yet.
Doing the deflection.
Okay, for the bedding, we need to see the arrangement. We need to know whether it's 4-point or 3-point bedding. We need we need to see all that. We need to see the calculation that you're doing. This is a progress.
Okay.
You can show us. We need to know that you know the formula used for calculating the compression. I mean, with the fracture. Later on during the final presentation, we can remove that and just show the summary.
Okay.
But as a progress, we need to see that.
Okay.
Okay. So next. Oh, we've spent more than an hour, almost an hour. I wanted it to be like 40 minutes. Oh, what was the previous one? The first one was
unreinforced plastic lumber.
Oh, unreinforced. Then next.
Reinforced.
Any improvement?
Just a small one.
Small improvement. Yes. This was average was 22.38. And the other was 20.753.
I think for future,
yes,
maybe you don't have many results, but in future, you need to show the average bar with an average, and then you show us the error bar, the range. Okay. Because now comparing, if they were together, if you are seeing a sample for unreinforced and then the other one for reinforced, we could appreciate the margin. Yeah.
Okay.
And the same thing, at the same time, in the methodology, yeah, that's why I was seeing this. It's a lot of information missing. We didn't see how you are reinforcing, how you place the fiber, the wire fiber in the matrix. We did not see that. And not just with photos, but with also the scheme, the sketches. We need to see your scheme so that we can see whether even the way you arranged, or did you just chop small pieces of wire, or did you use one long length of?
We use the strand.
The strand, we need to understand all that.
Yes.
So that you may understand, like if you use a strand and then you are doing the compression strength test, you don't expect any change in the improvement. Okay. But for us, actually, we are not so much onto that. And again, discussing your results here, and this is just something that have come to my mind. When you are discussing your results, you should be discussing your result focused on a problem that you want to solve. So discussing your result in terms of the modulus.
Okay.
So the issue of modulus should start coming into play when you are discussing this result. The Poisson's ratio, the improvement or the deterioration of the same. Okay.
Yes.
Yeah. So results are not just putting them there. You need to talk and read. Okay. And the first point I'm telling you, the first point of discussion is that, when you want to know how to discuss, is that go to those papers that you are referring to. Read, see how they discuss their result. You can even look at how they did their tests. You see where there are some tests you can try to emulate. Not just copying, but emulating.
Okay.
Yeah. Then let's see ahead, slightly ahead. Next. That was it.
Yes.
Okay, so you still have got some work to go. Your work is taking shape, but there is still a lot to be improved on, because like one thing, you see now why I'm saying that you need to do the tensile test, because you might end up, when you do the summary, like you summarize, instead of just having the compressive strength test showing us the different specimen, but you just show us the average. You know, that will be just one graph. Yeah.
Oh,
One bar. Actually, not one graph, just one bar. And then you show us adjacent to it, you show the other one with reinforcement. And then the other with T-bar. So you see, if you don't do the tensile strength test, your work seems so narrow.
Yes.
Yeah, so you need to, I was thinking even if the time allows and if you have enough specimen, you can conduct the same test again. Yeah, to have some large set of data. Nobody said that you only have to have 3 specimens. This is just the bare minimum we talk about.
Yes.
Yeah. Okay, let me stop there for now so that we can give you time to digest that. I understand this is a progress, so I'm expecting some improvement in future, but it's a good progress so far.
Yes.
Though we were expecting much from this, because if you really noticed from your presentation, people are curious about what you're doing. So you have to quench their curiosity. You have to make them see what you did and how it might be of a help in the future in terms of the performance. Because if you look at this, my motivation was on this. You said you went to Jijenge and you went to the other guys for the poles.
Yes.
If, for example, for the poles, I have never been there, but for the Jijenge, I've seen the video. You see the way they drop that tile, and that tile just have got, what is it? Just sand. You know, it seems unbreakable. So I was imagining the kind of T-bar that you can get. I mean, not T-bar, like the kind of the stresses that material, that specimen can carry. Okay. So I don't know whether I think I should also come and see this sample.
Yes.
Let's see. Today is Tuesday. Today being Tuesday. You are in the university?
Yes.
I think I'll be there sometime later today. So I would like to see this specimen because I would like to see how it's behaving in fracture upon applying the load bedding.
Okay.
Yeah, we were really interested to see how it's behaved. Of course, without the reinforcement, it might not be that much, but it might be interesting to see how it's performing so that we might even know whether it's material, the type of plastics that are used. Because for you are saying you use HDPE.
HDPE. Yes.
Okay, I know it's because maybe wherever you went there have that, but why not PVC? Why not UPVC? You know, that kind of a question could come into place that we see maybe some plastic are better than the other. Maybe the more settings are better than the more plastics. Okay.
Yeah.
But at this stage, let's just stick with what you're doing.
Yeah.
And then we see what kind of typical results that you get. But be prepared, read as much as possible because you expect people to ask questions in this. And also you also want to at least give people something worth their time.
Okay.
Okay. So I'll stop there. If you have any question, you can ask now.
So we meet on the college.
Yeah, I'll be there. Maybe at around 1-ish. But I'm having a meeting from 2:30.
Okay.
So if I don't meet you before 1, by 1 I can meet you after. Okay. But basically in the lab, okay. I want to see this specimen, and anybody else who is doing the test in the lab can come there. Okay.
Okay, thank you.
Okay, you're okay?
We are okay.
All right. So now you can make me the host or make Anastasia the host. Just do the way I showed you so that you can proceed. First is you stop sharing. And the people listening from YouTube, if you have any question, you can leave it on the chat section there concerning this presentation or something related to your work. if you have something that you have seen in this work and you want to get clarification for your research, you can ask that in the chat section, and then I will look at that.
Okay. We are making Anastasia the host.
Yeah, she is the host, eh?
Now he is the host.
Okay, Anastasia, take us through what you have. Share your screen. First of all, unmute yourself so that we know we are together.
Yeah.
Okay, now you can share the presentation.
Can you see it?
All right. Ah, yes, we can see that. Where is your friend?
I'm here. I'm present, sir.
Oh, after being lost for a very long time, eh?
I'm here.
Yeah, this is the work, both of you. So you need, because when I was, we were working on the proposal for approval. I was just seeing emails from Anastasia, and I didn't know whether you were participating. I heard that you had traveled.
Yes, I had, but we had already discussed about it before the emails were being sent.
So have you been doing any tests in the lab for this work?
Yes, we have.
Okay. All right. So let's start off about 5-minute presentation, then we have questions.
Okay. Our project was on comparison between undestructive and destructive strength test results for concrete mixes with recycled waste as fine aggregate replacements. The project partners, of course, Anastasia and myself. So next slide. The contents, background information, research gap, problem justification, objectives, scope and limitation, literature review, methodology, work plan, and the budget. With the background information, concrete is one of the most widely used construction material worldwide. One of the most important concrete properties for structural concrete design or redesign is the compressive strength. The strength of a concrete structure may have to be assessed without causing physical damage to it for various reasons. The estimation of compressive strength of concrete, there's the destructive test and the non-destructive test. For the destructive test, we have the compression testing machine. And for the non-destructive test, we have the Schmidt hammer or rebound hammer, the ultrasonic pulse velocity, combined method UPV and RH test, the co-extraction for compressive tests, among others. So here we have the diagram, we have the photos of a Schmidt hammer and the compression testing machine. So the fine aggregates are important components of concrete. Use of recycled wastes as partial replacement of fine aggregates is gaining popularity. Testing of these concretes is necessary. The recycled waste tested in this research as partial replacements for fine aggregates are HDPE shavings, the quarry sand, and aluminium shavings. The research has been done to come up with factors to use while comparing non-destructive tests and destructive test results for several situations, such as different water to cement ratios or sample sizes, but there has been no similar research done comparing concretes incorporating recycled waste as partially replaced fine aggregates. So partial replacement of fine aggregate is becoming a recognized construction alternative in Kenya. Therefore, a comparison needs to be done using destructive and undestructive tests to obtain factors for the different partial replacements. Our main objectives to compare destructive and non-destructive test results for concrete made by partially replacing fine aggregate with HDPE shavings, aluminium shavings, and quarry sand. Other objectives are to determine compressive strength of samples using destructive compressive strength test and non-destructive rebound Schmidt hammer. To compare the results obtained from the tests performed on concretes with recycled HDPE, aluminium powder, and quarry dust. And also to determine a correlation factor between destructive and non-destructive testing techniques for each concrete type.
So for scope limitation, this study entails a comparison of destructive and non-destructive tests, compression tests, by testing concrete samples with different recycled wastes used as partial replacements for fine aggregates. So the limitations that we have is that the preparation of the materials used to carry out this test is time consuming and expensive to do and to acquire the materials. And also due to lack of enough time, the tests on the cubes after aging cannot be carried out since the non-destructive tests are mostly done on aged concrete. So in our literature review, we have authors of Atoebi et al. 2019. They did research on reliability comparison of Schmidt rebound hammer as a non-destructive test with compressive strength test for different concrete mix. So the findings that the destructive and non-destructive tests were done on concrete mixes with varying cement ratio. The critique was that the study just focused on the testing samples with varying water cement ratio, and there was no recycled waste incorporated in the concrete mixes. Shankar and Joshi did a study on the comparison of concrete properties determined by destructive and non-destructive tests. So the findings were that the non-destructive tests are suitable only for controlling and estimating the compressive strength within the specified range of the target object, and the sample objects for the comparison should be as close as possible to the target object. For the critics, the non-destructive tests used were Schmidt hammer and UPV testing machines. Testing was done on cube samples of varying sizes, and cores taken from existing structures. We also reviewed Malik and Puthar destructive and non-destructive testing of concrete structures was the title, and the finding was that the difference between the values of resistance obtained by destructive and non-destructive tests decreased considerably at the age of 28 days. Also, the rebound hammer test can be used to evaluate the compressive strength of old concrete and not young concrete. So for the critic, both rebound hammer and UPV machine were used for non-destructive testing, and an equation was also proposed to estimate the relationship between rebound number and dynamic modulus of elasticity for concrete for 28 days. Also, the water cement ratio was varied. Tamrin and Nudiana did a study on the effect of recycled HDPE plastic additions on concrete performance. Tests carried out on the concrete showed an increase in compressive strength and of concrete. The lamellar particles that were used of sizes 10 by 10 millimeters and 5 by 20 millimeters remained unaffected by coarse aggregate pressure during casting, as opposed to the other sizes used in their testing. So the testing method used in this research was destructive only, and the form of HDPE used were big lamellar particles that were used to act as a replacement for coarse aggregates. So in the methodology, we were only able to do, so far we've been able to do particle size analysis of fine aggregates, and this was done on samples of 500 grams of river sand, HDPE shavings, quarry sand, and the sieves used were 10 millimeters, 5 millimeters, 1.25 millimeters, 0.6, 0.3 millimeters, 0.18, and the pan in that order. So this is the results that we obtained. This is the distribution, particle size distribution curve that we got from the results for the river sand. This is a particle size distribution curve we got from the results obtained from sieve analysis of the HDPE shavings. And this is what we got for the sieve analysis of the quarry sand. So that's our work plan and the budget at the end.
Okay, I was worried because you have been reading too much in the literature review. So I was wondering whether we'll be able to finish on time, but I've just realized that you foreknew that you didn't have much progress. So that's why you spend too much time in the literature. Eh?
Yeah.
Okay. First thing first. Of course, the general comment you have heard about them today, so no need to show us the budget and all that.
Yeah.
Okay. I have kind of a feeling. I know this is we are in which week now? It should be the fourth week.
Yes.
How is that
The
progress? Sixth or fourth?
This is fourth or fifth. Not sure.
I think it should be fourth. So now I'm wondering the progress. If you just been able to do the grading, the SIF analysis.
Yeah, we had a bit of a delay in acquiring the materials.
Hmm.
Yeah, okay, so that's, but from now on, now that we have them, we're going to move at a
Okay.
fast speed. Yeah.
Okay. So how are you getting these HDPE savings? I mean, from preparation, how are you obtaining them?
We got the shavings from a recycling plant that deals with plastics.
It's good, and the methodology to show us those photos,
Okay.
Show us those we see. When you talk of shavings, what kind of I mean, by visual illustration, we can try to have an idea of what kind of material that you're talking about, the type of the sizes and all that.
We'll include them in the next presentation.
Yeah. Then in the literature review and also throughout your presentation, but specifically literature review, don't read those sentences. Yeah. Okay. Don't read them. Otherwise, I mean, it may portray a bad picture or an image concerning your preparedness. Because if you read word by word, somebody may think this person just copied and left the work. They have not internalized. So that's what you did in the literature review section. So improve on the presentation style. Then can you go to the literature review before we count the result? Because you don't have much of the result. Literature review, the second slide, the second part of the review. Yeah, the first by Malek, 2014, in the critic. First of all, let me say the critic. The critic is where you are talking of the gap. What you think can be added in that work or what was missing in that work. So basically, in this objective, the first row, what is that a critic really?
For both the rebound hammer and the UPV machine used.
Yes. Yes.
No,
yeah. So that column, I don't see a critic. Okay. The second part, the second one, of course, when you say testing method using this such was destructive only. Okay. But for the one on top, the first objective in this slide, the first reference in this slide, I think that's not a critic. Well, there's something that I wanted to see here. You're saying they are doing, they're using rebound hammer. They come up with an equation. This is a very good reference point for your work, because this will form, if you know what you are supposed to do in objective number 3, the correlation. It's about coming up with an equation. And then coming up with an equation, if you want it to be, it's about regression. If you're going to do, if you choose to go the regression analysis, it's good to have some significant, the large quantity of data, so that when you draw the best line of fit, you are not just going to plot using 3 points. Yeah. So note about that. Then I'm looking at this. They're saying their test was done for 28 days, is it?
Yes, they tested, the final test was at 28 days.
Can you go back to your limitation? What did you say here? Due to lack of enough time, test on the cubes after aging cannot be carried out. What does that mean?
That was meant to refer to like cubes or samples that are more than 28 days, say maybe more than 2 months going on.
And when you are explaining, if I'm not wrong, and you see this is recorded, I mean, you can watch it later on YouTube. So if I'm not wrong, if I got you like that, did you say that Schmidt hammer will not be used for young concrete, maybe 20? Did you say something like that?
That was in one of the articles. That is what they had suggested.
So I wanted to know, by saying young, what type of the age, the days are you talking about?
Okay, in that article, they tested up to 28 days, and the results that were obtained for less than 28 days were not satisfactory. So from 28 days onwards is when, at 28 days, they got better results. So that's why they suggested it's better to be used on.
Okay. Yeah. Okay, I get it. For sure. Yeah, at 3 days, if you use Schmidt hammer, you're just going to make impressions on concrete. You're just going to make, you hit it and then it's just in a bodega, is it?
Yeah. Because they tested 7, 14, and 28 days. Yeah.
Okay. So in the limitation, I believe to come out clearly, you could say the durability test will not be conducted. So when you say durability test, people know that you're talking of long term.
Okay.
And somebody knows durability test, even you talk of a near plus. Okay. Of course, there are some tests like water absorption which infer to durability. But if you're saying you are testing the issue of like creep, those are tests for 365 days and above.
Okay.
Yeah. So let it come out clear so that we can understand there.
All right.
So preparation of materials to carry out tests is time consuming and expensive. Remove that.
Okay.
Yeah. Let's just remain with the issue of we are not doing the durability test. Then your slide is good to put slide number so that we can refer to a specific slide.
Yeah.
Then let's go to the result. No, before we go to result, let's go to, can you show me the problem statement?
The research as a problem statement.
No. We need a statement of the problem. Yeah. Usually, research gap will come after you have shown us the literature review in chapter 2. Is it? Where you have the summary and the research gap. But the problem statement comes immediately after the introduction, the background information.
Okay.
After you have described the problem, I mean, you have told us the broader picture, the existing scenario, then you show us like you are making a statement. Remember, and even for those people who are writing their document in the statement of the problem, they start giving new literature review. The more you explain much, the more you might be lost. I'm not saying you cannot have literature review or some reference in the problem statement, but let your problem be like of summarizing. It's drawn from the background information. Let us understand the existing scenario and what is lacking from the existing situation, so that now the research or the problem statement is a statement which emanates from that. I don't know whether I'm confusing you more or I'm making you clear. So first of all, your work, you need to put the problem statement, and number 2 should be built up from the introduction. You cannot have research justification, a given objective without having the problem. Yeah. Because if you remember when you are talking of how to develop a research title, a research topic, we come from the idea, then we do a literature overview, we have the problem, we formulate the objective, then you have the topic. Okay.
Yeah.
Then in the background information, can you go to the slide where you are talking of I stop there. I'm looking at this chart. It's a good summary. I like this kind of slides, where you do not have my sentences and all that. This is a PowerPoint presentation. But I'm looking at the non-destructive test, the last one. You're talking of co-extraction for compressive strength test. That is non-destructive.
in terms of the sample, as in the sample is gotten from a building, so you wouldn't have to like destroy the whole building.
I think I don't know, from literature, is that how it's classified?
Yeah, that's how we saw it.
I don't know, maybe you read an Indian book. Anyway, to me, I would think like co-extraction to be a destructive strength test. Do this. Let me give you a short assignment. Just go in the lab. There is a book by Neville. I don't know whether they are still there or whether the second years have taken them, but it's called Properties of Concrete. You read that book and see, just go to see whether the co-extraction, because you take the specimen. I'm not even looking at the issue of destroying the building, but I'm seeing you go, you cut from the slab, if it's like you want to get the strength of the slab, and then you bring that specimen in the lab, you crush it, is it? You destroy it.
Yeah.
So to me, that sounds more like a destructive test, a strength test. But confirm with the proper literature, like the one I've given by Neville. Neville is an authority in concrete. Objective 1 and 2. What was it about? Yeah, I wanted to understand. What is the difference? Like results. What type of result are we going to see in one? Like for each objective, you're going to see the results you presented in terms of charts, graphs. So, what type of results do we have in one, and what type do we have in two? Like, what's the difference?
Okay, so for the first objective is just to obtain the strength, just to obtain the values from the tests, and then now the second objective is to do the comparison of the results we obtain, and then now we come up with a correlation in the third objective. Yeah.
Wow. It's only that people insist on 3 objectives, but to me, well, I know you like when I tell you to give me the result for objective 2, different from objective 1, you will not have. In terms of discussing, yes, you might have, but in terms of results presentation, because we just be talking about the results in objective 1. Okay. You see, in objective 3, yes, you'll be picking the result in objective 1 and 2, but now you'll be plotting another curve, and now you want to see the correlation, and you suggest maybe an equation, is it? Yeah. So it have got its own result, a starting result, yeah, distinct result. But when you plot the graphs in one, and bar chart and line graphs and all that in one, then when you start discussing those results, you may find like you are comparing already in that objective. Okay, so I don't know whether it's necessary to reformulate this so that the objectives are distinct.
Like we could merge the first and the second one to be one.
Yeah, but my concern is that the other panel members, I don't know why they always think 3 objectives is good. I found a question being asked, somebody with 2 objectives. Are those enough? Yeah. For me, I believe you can even do a research with 1 objective, as long as it's well defined. Okay. Think about that,
Right.
Think about that. I was maybe thinking the first objective to be material characterization using the normal destructive strength test. So the second one now is when you introduce the NDT so that you compare. I'm just trying to look at how we can.
Because what we had suggested, in order to not make the process very expensive by having to like cast twice, we were suggesting we could start with a non-destructive test and then we do a destructive test on the same samples. Is that viable?
Oh yeah.
Yeah.
That one will not affect the number of specimen, I'm talking about separating so that, okay, because we are still at the progress and you are not presenting to anyone at this stage, okay, let them stick like this. But let's see, when you come to the result sections, let's see whether we can be able to separate, to single out the result for objective 1, whether they can stand alone. It's always like this for those people who might come back and want to proceed. The question is, can I be able to write a full paper, a standalone paper on the first objective? Like I say, I have finished the first objective, and then I can be able to produce a publication from that. You see? So if you publish something in objective 1, then I want to see in objective 2, do we have something distinct? Okay?
Okay.
Yeah. Yeah, I can see Humphreys Murray is here. Humphreys Murray, compressive strength test is indeed a destructive test. It's put that the stress is achieved. Yes, Humphreys. Humphreys, I think, is in 4th year. Oh, good. Good that you have joined today. If I'm not wrong, maybe he's in 5th year. I don't know. Now, but the question, Humphreys, for you that I'd like you to check out is, the argument was on the concrete core cutting. Yeah, this is a question that somebody have asked on in the YouTube, the chat section. Okay, so for now, let them stand around like that. It's okay. But when we count the result and discussion section, let's see whether we can be able to distinguish between the two objectives in terms of the result and their discussion, without seeing like number 2 is a discussion of 1 that it cannot stand alone. It doesn't have its own result. Okay.
Okay.
So think about that. You don't have to change it now. Think about that. But when you start discussing your results, now you can start thinking whether we can reformulate these. Just the retro twist.
Okay. Okay.
Okay. Move to the.
Hello. I can't hear you, sir. Hello. Hello. Excuse me, sir. I can't hear you.
I think he's not in the group currently.
He's left.
They only okay, now he's back.
Oh.
Sir, can you hear us?
Hello, Anastasia.
Yes.
Hello.
Hello.
Oh,
Yes,
you can
sir.
hear
I
me.
can hear. Yeah.
Sorry, I lost the internet because the power went off. So I had to connect with my phone.
Okay.
Sorry for that. Sorry for that. I can see Humphrey's Murray is here. Humphrey's Murray compressive strength test is indeed a destructive test. I want to see whether the other people are connected. Oh, sorry for that.
Okay.
I can't hear anything from there. Okay, I think I'm back. I think I'm back from that. So, oh, sorry. Good. So if you can hear me, let's go to the results section. Anastasia, go to results.
It's there.
Okay. You showed us this grading curve. Huh? You know, when you make you present your results, it's always good to tell us what they imply, what's the meaning about it. First of all, you need to show the limit, is it? Okay. The lower and the upper limit. And then you need to discuss to us, because first of all, you have to understand, why do we do grading? When we are talking about the test with concrete and all that, why do we start with the grade? So that once you understand the significance of a test, you'll be able to discuss the result that you get. Like now we have this curve. What do you say about this curve? What is it about?
We did this to find out if the materials, the fine aggregates, were well graded, so that we can be able to proceed to create our concrete samples.
Okay, well graded, but in the discussion of your results, I mean, you didn't say anything about it. You just said this is the result we got for the grading of the riverside. Then you showed us the grading of the shavings. I mean, so from this curve, how do we know whether it's well graded or not?
Well, okay, I had not yet finished properly. I'm supposed to get the values for the D6, D30, and D10 for each curve, and then now from then I can properly analyze it.
Yeah, but at the same time, at least for every progress meeting, you may not have many. I mean, much. Is it much or many? Much result, but at least for what you present, for part of it, it's good to have some explanation. We also talk of the science behind, so that we do not just have a presentation where we are just saying these are just the results you have seen and that's it, and we do not even tell what they are talking about here. Like here, for the grading curve, just as a pointer in the good direction, when we show the limit, the lower and the upper limit, if the curve falls within those limits, of course, we are trying to check the conformity of the materials, whether they meet the standard. So if it's within the limit, if it's outside the limit, we have to do the blending. If it's within the limit, then we say it satisfies the requirement, and therefore we can use it according to the certain. I don't know whether it's I can't remember the BS number, and also according to the BRI method of mixed design, we can be able to use this material without the need for blending. Okay, that's now kind of an explanation. If, for example, you're talking about the grading of the soil, we talk of the soil classification. The unified classification. So from the grading now, you can start taking values. Remember, from the result you show us, you start talking of you discuss your results using this curve, but now you become quantitative, not just showing us this graph. So you can tell us, if you want to tell us whether it's well graded, it's fine graded, it's gap graded. You can say the particle size between the 10 and maybe between 5 and 7 millimeters was the highest proportion. We're having 70%. You know, those kind of statistics. Yes, you derive them from this curve, but it depends with what you want to discuss about this curve, right? So that's another direction you can take. If you want to talk about the grading, whether it's well graded, gap graded, whether it's, you you talk of the percentage within this limit, and then people can see from the graph. If you just want to ensure that it conforms or it's within the limit, you just show the limit and tell us it conforms within the specification according to this standard. You tell us this is that standard. Therefore, it can be used for the mixed design following this method. So for each result you present, you must have some explanation. And that's why it's better you have some results now. If you showed us this and then you show us the results for the next objective that you are doing, then you can tell us this is what we have done. Now the next one is this is the progress, is it? So yeah. For this part, we have not discussed maybe A, B, C, D, but at least at any progress, let's have the result that you have discussed and given us some scientific explanation. And this is not from you, yeah? Once you get the result, you just need to read from the paper, from the book, like I have referred to you, that by Neville, the reference papers that you are giving us, then discuss your result based on the literature. We are not saying that you bring new knowledge. In fact, for undergraduates, the contribution is very, very small. Yeah. And even at the advanced level, you may find like the gap that you are handling, it's just very small. But sometimes at undergraduate, we want to show that like you are doing too much, you know. We are solving a very big problem, which is not usually the case. So let's have those literature review, and then let's use this information literature review for discussing our results. Okay? Okay. So allow me to stop there, and then welcome any question from you, from your colleague, from anybody else, either in YouTube or in Zoom. You can ask your question here if you have any.
If it's possible, you said if you've been in school today, in our document, the Word document, you had suggested that we need to talk about the table that we had put for the ratios before we start casting. Yes, we wanted to discuss that with you.
Oh, okay. Then we can meet.
Okay.
What I'm not very sure about is I know after this now I'm in the other side, the west side of Nairobi. So after this, I have a short errand I'm going to run along Baker Road. So by the time I reach there, we have a meeting at 2:30 in the department, exam board meeting, 2:30. So basically, if I arrive there by maybe 1, we can have 1 hour of talk. So if I arrive there late, then we can have after the meeting, maybe from 4:30 there. So just hang around. I know you are in school, so just hang around. Then I'll just communicate in the WhatsApp group when I'm available. Okay. Right. Okay. Anyone else with any question whatsoever? So Humphreys, thank you for joining, and I think it's high time you start developing your concept after you listen to this presentation. Sometimes if you wait until February without having an idea, you might have problems. Like now I'm impressed with some lady in Fodia who is writing a paper to the IEK conference that is to happen in Mombasa. Yeah? I'm impressed for that. And I know that the work that we are doing here is not in vain, because he said that he's been following the lessons that we have been giving on about the research and presentation. And that's our hope, that somebody might be assisted. Okay? We are okay?
Yes, we are.
You can stop sharing now to see whether there is anyone else on the chat. Okay. All right. Anyone, you are okay? All of you are okay? Today, did Nani join? Who is this? Mohammed and Faisal, you are together with us, So for those people who are yet to present, next week we have the next 2 groups. Next week we shall have Jesse and Peter, and then Mark and Dennis. So at least try to make sure that your work, there is a progress more than what you have seen today and last week, because of course time is moving. We expect to see more results, more discussion, a great improvement compared to what your colleagues were discussing about. Okay. So that's it. I'm glad that you were able to finish at least 1.5 hours because that's my target. Then here, the effort that you are putting here is not just to pass time. I'm assuming that not only for the purposes of the grading and school scores, but in future that you are improving on something that can help you out there when you talk about handling problems. You know, it's about problem solving. Engineers are problem solvers. How you can formulate a problem and then you can be able to add the skills acquired, you can apply them and do a presentation of what you have. Because again, if you have very good results and some very good knowledge, but you cannot be able to impart to somebody else to deliver to people, then it might not be quite helpful. Okay. All right. I can see Mohammed is there. I just wanted to make sure that at least it's just 1.5 hours. I'm trying to put it at maximum 2 hours. We are here together. We help improve one another. And then allow me to add there to stop there. If you have any question, let's meet at, in the afternoon. We agree on time. And then if you have anything you need to clarify, then we can clarify it that time. So bye-bye for now. Thank you for attending.